All right, this is on direct and joint variation. One type of linear function is called a direct variation. It shows the relationship between two variables, x and y, that can be written in the form y equals kx. K is going to be the constant of variation. We say this as y varies directly with x. So here is your equation. This is how you say it, and this is called a direct variation. A direct variation equation in the form y equals mx plus b, where b is 0, then the slope is going to be your k because b is 0. That's your y-intercept. Okay, starter. This linear equation, distance equals 60 times time, describes the distance traveled as a function. So we have 3 hours have gone by, so the time is 60 times 3 is 180 miles. Then 60 times 4, we've traveled 240 miles. 5 hours, we've now traveled 300 miles. So again, we're just multiplying the time times 60, and then we continue this. We get 360 miles, 420 miles, 480 miles, and then 540 miles. This is a direct variation equation. Notice as the time increases, so does the distance. So both of these are increasing. So if we were to graph this on a coordinate plane, the time would be your x-axis and the distance would be your y-axis. And then these ordered pairs are going up like that, creating this nice line. Here are the steps to writing and graphing a direct variation equation. First thing you do is you set up the variation equation. Then you find the constant of variation. You want to rewrite the equation with the constant in it, and then answer the question using the equation with k in it, and then graph when asked. So here's an example. Y varies directly with x, and what we're giving you is the value of y and the value of x. So step 1, is to write the variation equation. So we're going to go ahead and substitute the y and the x into the equation. Step 2, we're going to go ahead and find it. So the 27 is the y, and then the 6 is the x, and we're going to solve this for k. So we divide both sides by 6. So k equals 27/6, or as a decimal, 4.5. Step 3 is to rewrite the equation with k in it. So we're going to take this 4.5 and substitute it in for k. So step 3, replace the k with 4.5. Step 4, we could answer the equation. In this case, there isn't a step 4 because we're not finding or making predictions. And then step 5 is to graph it. So what we do is we go over to our coordinate plane, and we're graphing y equals 4.5, x plus 0. So the slope is 4.5, over 1, and the y-intercept is 0. So we graph our y-intercept, and then we go up 4.5, and then right 1, or down 4.5, left 1. So that creates our line. Example 2. The circumference of a circle C varies directly as the radius r. And then what we do is we give you the circumference and the radius. And then we want to go out and make a prediction when we have the circumference of 4.5 pi, what is r? So step 1 is we want to set up our direct variation equation. So right now it's y equals kx, but notice our variables are not x and y, they're c and r. So the circle C, so I'm going to just change that to the letter y. So think of that as your y piece. Varies directly with the radius r, which would be the x piece. So when we set up our equation, C equals k times r. Step 2 is to find the constant of variation. So we want to find out what k is. So now we're going to use these two numbers. So the c and the r have been given. So those are going to go into the c and the r. So 7 pi equals k, and then 3.5. And in step 2, we're going to solve for k. So we want to get k alone, so we're going to go ahead and divide both sides by 3.5. And then we type that into our calculator. We get approximately 6.28. So that's our constant of variation. Then we're going to go ahead and substitute the k into the direct variation equation. So before it was c equals kr. Now we're going to go ahead and substitute k in. So we get 6.28 goes in for k. And then we're going to go ahead and answer the question. So up above here it says, the question is, find r when the circumference of the circle is 4.5 pi feet. So we're going to let c equals 4.5 pi, and we want to find r. So 4.5 pi is going to go in for c. And then we're going to solve this for r. So we divide both sides by 6.28. And then we type this into our calculator. So r equals 2.25. So what did we just find? We found the radius of the circle to be 2.25 feet when the circumference of the circle equals 4.5 pi feet.